Welcome to another video for General Science. In this video we're going to complete our Simple Machines lecture. This is part 2. So the last time we left off with an inclined plane, okay, and the mechanical advantage that you gain from using a plane as opposed to lifting an object up directly from the ground onto a certain height. So let's continue on. So this is the fourth out of our six machines, the wedge. So here I have a simple diagram explaining how a wedge, or showing how a wedge works. So you'll notice on the input force at the top of the diagram, that's where the force is applied by you, by the person. And then on the opposite end of that, you have the actual wedge. Okay, so it narrows down to a point. It narrows down to a point where it can go in between two surfaces. And you'll notice that as the force goes down, the input force is pushing down, okay? You're going to have a force, two forces that push outside. So your output force pushes outside. Think of it in terms of an axe. So when your axe is a wedge, when you push or you swing down on the axe, the wedge comes in contact with the wood and it goes in between the wood and it splits the wood. And you'll notice that if you've ever gone chopping wood, you'll notice that the two opposite ends of the wood will actually fly outwardly. Okay? So you push down, you press down, yet the objects fly apart and they fly in an outward direction. Same way with a knife. A knife, when you slice an apple, the apple opens out. Okay? So here's your ideal mechanical advantage ratio that you're looking for. Distance along the wedge over the change in wedge thickness. So the smaller the wedge thickness is, the more mechanical advantage you'll get. The easier it is to break something open or slice something open. So it's kind of like a knife. I don't know if you've ever heard that a sharp knife is actually more safe than a dull knife. Okay, and this is the physics behind why that is. Because a sharper knife has a thinner wedge. Okay, so it has a greater mechanical advantage. It cuts through fruits and vegetables more easily than a dull knife will. All right, so let's move on to our fifth, the screw. So here is the ratio: the distance the screw is rotated through over the distance the screw advances. This one can be a little confusing, but let's look at it this way. So you'll notice I have a couple of screws here. Notice the threads on the screws. Okay, they're kind of diagonal. Now it's better to think of a screw as kind of a mini little mountain. So let me ask you, if you're climbing a mountain, is it easier for you to climb the mountain going straight up? Now, that's the way I would love to climb it. That's the way I climbed mountains. But it's easier to take the trail that winds around the mountain, isn't it? Okay, that's an inclined plane, if you will. Okay, so that disperses the amount of force that you need to press it down. It disperses the force through an inclined plane. So think of a screw as an inclined plane, because as you notice, those wedges are inclined. Okay, there's an angle to them. So the more threads that you have and the closer they are together, that actually increases the mechanical advantage that you have, which makes it easier for you to screw that screw into another surface. Okay, so think of a screw as an inclined plane. And again, the smaller, the thinner, or I'm sorry, the less far apart they are, the closer they are together, the threads, the easier, the more mechanical advantage you gain. Similar to a mountain that has a windy trail that goes all the way around. Okay? All right, so last but not least, we have a pulley. So you gain a more mechanical advantage by increasing the number of rope segments supporting the load. Let me show you what I'm talking about. So you'll notice here I have one rope segment attached to my object. That object is 100 newtons, so the force of gravity and its weight are pressing down, and you have one pulley, a fixed pulley, and you're pushing down, right? Remember, that's one of the ways that work is made easier, is by changing the direction of the force. So you're pushing down on the force, and the object is going up. Now you'll notice that you have to apply the same amount of force that that object has, which is 100 newtons. Now look at what happens when I add another pulley. Okay, you'll notice that this pulley now has two rope segments. Okay, these two rope segments are actually dispersing the force that you are applying. So two rope segments divide the amount of force that's needed to push up the object. Okay, so if you look at the rope segment that the individual is pulling on, that only requires 50 newtons of work to lift a 100 Newton object. Now look at what happens when I add another segment. Now you'll notice that the force is being distributed through 3 segments. So that means when I'm pulling down, I only need a third of the amount of force to push a 100 Newton object up. Okay, now we're assuming here that none of the force is being leaked out or wasted on friction. So the friction points for this particular mechanism would be the actual pulleys themselves, because as the pulleys turn, they can rub metal with metal, or also where the rope comes in contact with the pulley. So these 2 points are points at where friction can be created, and some of the force that you apply can actually be leaked out that way, requiring you to actually pull a little bit more than just a third of the force. All right, now what about this one? We have 4 segments. So again, a pulley, the more segments that you have, the more dispersion of the force that's being had. So that only requires, with 4 pulleys or 4 segments, that only requires a fourth of the amount of effort. So you only have to pull down 25 newtons to lift up a 100 Newton object. And here we have with all 4 of the types of pulleys that we have, that you can compare them. Okay? Okay, well, that's the 6 simple machines. This is part 2. Okay, these are the questions that we dealt with in this video and the previous. What are the 6 types of simple machines? And what determines the mechanical advantage of the 6 types of simple machines? Okay, that does it. Thanks for listening, and good luck with your studying.